And we are very happy to host Shajay Bhooshan from Zaha Hadid Architects. Shajay is an architect, a designer, an expert fabricator. And with him we are exploring different techniques on how to scale up our ideas and also how to turn these design solutions into fabrication strategies. Shajay Bhooshan is a senior associate at Zaha Hadid Architects, where he co-founded and heads the research activities of the Computation and Design group. He also works as a studio master at the AA DRL Master program. He pursues his research in structure and application, aware architectural geometry, as a PhD candidate at the Block Research Group at the ETH Zurich. Previously, he has been working at Populous in London and completed his M.Phil from the University of Bath and M.Arch from the AA School of Architecture in London. His current interests and responsibilities include developing design research and maintaining computational platforms for the same at Zaha Hadid Architects. He has taught and presented work at various professional conferences, events and institutions across the world, including the Architectural Association in London, the ETH Zurich, the Polytechnic of Milan, the Dongjing University in Shanghai, the SIGGRAPH, the University, and he cannot be happier to be with us here at the IAAC. So please let me welcome Shajay Bhooshan.
Yeah, thanks a lot for the introduction, Aldo, and firstly thanks to Alex and Aldo to invite us to do a workshop here for a week, and also many thanks to Kunal for supporting the workshop, and Laura and Anna and Sylvia and others for supporting the logistics. It's always great to be back in Barcelona. We've had ongoing relationship with the Institute through our studio and also as personal friends with Alex and Luis and a whole bunch of others. Finally, many thanks to RND for the invitation as well, and in general, like continuing association with things that started informally and now beginning to become more formal. So it's a pleasure to be here, and hopefully we can have a lively discussion after, because in general we live and work in London, and we have strong opinions on certain things, and we like to be discussed and challenged, and so we're hoping I can keep the presentation as precise, and hopefully there's some discussion after. Okay, so the context of the talk is obviously in relation to digital design, digital fabrication, and more specifically, like in relation to the question of where next, considering there's been a sustained period of like maybe 15-20 years, at least in the UK for us. The turn of the millennium was a big set of projects that like tried to push digital fabrication and computational design forward. So it's almost 20 years, and also this year we're celebrating the 20th year of like AA DRL. So in that sense, like it's a natural question for us to ask, like where next, considering that digital design and digital fabrication and robotic fabrication and construction is rapidly maturing, and then the questions become obvious as like questions originally asked by people like Cedric Price and others, like as architects, how do we position all of this technology? What kind of questions should we ask, and how do we take it forward? And so the presentation or the talk is generally about focusing. Some of our efforts in the last 1 to 2 years have been trying to ask the question, what is the social value proposition of digital design, digital fabrication, etc. So hence the question mark, and more specifically, like most of you who are here, who are practicing in the domain, must have spent like most of their careers like thinking about architectural production, the physical side of architecture, and perhaps even like the more scientific side of the profession. And we think it is about time to like begin to think of how architecture is consumed, i.e. how people use spaces, and how they navigate through them, and so on. So it's also about the storytelling aspects, like the narratives and so on, and to study that equally rigorously and equally computationally, let's say. And for most of our work, like in this regard, like computer games and computer animation are a deep source of inspiration and reference, because we think like over time they manage this dichotomy rather well. Like when you now look at a Pixar movie, you barely think that it is actually digitally produced, because the storytelling is so convincing and equally in depth and matches the technological sophistication that has gone into it for the last 50 years or so. And likewise in the automobile industry, like one of the aspects is that we like to tend to refer to the Henry Ford model as like being the kind of forebearer or the classic example of disruption, whereas most of the revolutionary changes came with the invention of the automobile, but it became disruptive only when they tried to take it to mass production and to make it mainstream. So usually like the revolutionary part is not the same as the disruptive part, and there is a period of sustained disbelief or suspension of disbelief needed for the revolutionary part, and then it's quickly followed by kind of taking things to mainstream and thereby causing some kind of disruption. And the second aspect is it's usually assigned to the success of the Henry Ford model is assigned to the assembly line production and the innovations in that. And obviously it has a large part to play in that, the kind of refinement of physical side of automobile production. But often understated is that like the car was also positioned as a lifestyle choice, central to the family in the 20th century. And it's also partly due to this kind of repositioning, rebranding, rethinking of the car, that like together with the innovations in the physical side of things make the car like almost the icon of an entire century. And it has deep effects into our cities, into the way we live, and so on. Closer to home, in architecture, it's also the case that like oftentimes now that when we look back at Gaudi and others of that time, and even perhaps even more back in history, we tend to focus on like the form finding tools and like the rule surfaces and the stone masonry and so on. But anyone who's visited the I don't need to preach to the choir, it's like definitely much beyond the fabrication technology and the structural technology at the time, because for the most part he used what was available, but nonetheless the building transcends like the technological aspect because there is a deeper search in the storytelling aspects of the building and his work in general. And it's also true for other technologies in the 20th century, like reinforced concrete, which required the innovation of like several kinds of industries and several kinds of people, everything from material engineering to trade schools to reinforced concrete calculations and handbooks and so on. And at the same time, it required like the invention or at least the proposition of a kind of architectural diagram which was suited for the technology. And 100 years from then on, 1915 to 2015, like we can see the effect of that diagram spread throughout the world. And all research in practice and embedded research. And in this sense, we're deeply inspired by and reference people like Ray and Charles Eames, in as much as that they invested a lot of time and effort in purchasing this patent from from the US Army, and therefore kind of spending a lot of time on the material side of thinking, which is very much suited to digital fabrication and that kind of thinking. But at the same time, they were the early pioneers or adopters of like supporting software in digital design, including the use of Mathematica and so on. But more importantly, they were one of the earliest to realize that like design and a vocabulary of materials and techniques, which we can now say is digital design and fabrication, is somewhat like that like we're in search for a vocabulary of materials and techniques and how to design for this. That is all but like a small part in a large ecosystem of things that need to be delivered and collaborated and coordinated with, including understanding behavior, economics, logistics, and so on. And in that sense, when they first did propose case study houses alongside several other architects of the time, like they already had this kind of manifesto and understanding of the larger picture of where technology fits in. So we tend to want to follow this kind of pathway. So we invested a lot of time early on, like for 10 years or so, understanding technology, and now slowly we're spreading our wings a little bit to try and apply it. So at Zaha Hadid Architects, we are fortunate enough to be able to work on unique one-off buildings. Fortunate in the sense that Zaha built this for us, and unfortunately she's no longer with us, but at the same time it was always part of the intention that like we're not just going to be making unique one-off buildings forever and restrict ourselves to that. What it does give us the opportunity is unique one-off buildings like allow us to develop expertise in geometry, in fabrication, in structures, on the physical side, enough so that it liberates enough time to address some of the other deeper concerns, let's say, of or less clear concerns of architecture, including how it is consumed by the users of architecture. So increasingly we're like now trying to distill from our experience of unique one-off buildings things that can be applied or generalized for things like architectural tasks, like housing, for example. At the same time, never forgetting that like we need to continue to innovate and keep track of all the innovation that's going on in places like the IAAC and at ETH and ICD and so on. So, which is not our core expertise, but we want to keep track of and have a good overview and understanding of all these technologies so we can design for these technologies and design for the digital, design for digital fabrication. And one of the reasons we make prototypes is so that it is internalized. Like, so when we design the next building, like we already have a good intuition of like what that technology implies and so on. So the Zaha Hadid Computation and Design group has been active for about 11 years. We're like a small percentage of like the larger company. And more or less like we divide ourselves into 4 tasks, like research, practice embedded research, and projects like special interest projects that are, and these 2 take up most of our time. And we try to interrelate them as much as possible, and then like we also try to participate in exhibitions and communication of the discourse and the ideas that are collectively evolving, and also we are the kind of conduit for internal talent development and also network development across our industry. So we want to be the kind of connective tissue or catalyst between academia and industry and the rest of the Zaha company. So largely the research has been divided into the deepest research topic that we have researched for the longest time, since 2009, is about shell structures and textiles and form finding and these kind of things. And another topic which I'll probably briefly touch upon for the remainder of the talk is the idea of curved origami or curved crease folding. But we've also spent some time increasingly in the last 2 years like on 3D printing with high resolution 3D printing with polymers, larger scale 3D printing with plastics, and also I'm doing my PhD on designing for concrete printing at the Block Research Group in ETH. And for the large part, these are the kinds of things that we tend to do, and this is what we call research. Getting inspired by computer graphics and like looking at the algorithms and so on, because it's not only intelligent but it's also fun, and it also makes transference of, like, if you can do it on a bunny or a dog, like it's somewhat easier to do it on a facade surface, for example here, retiling based on curvature, for example. And the key tools are entirely geometric, so there's hardly any numerical intuition. It is everything to do with simple entities of geometry, things like vectors and points and lines, and nothing more. Nothing more than 10th grade, 11th grade math, but everything is visual, everything is geometric. So we tend to want to reason geometrically, and so most of our work is based on a kind of geometry-based reasoning, as opposed to a numerical reasoning. And you can see that helps us, once you have across the scales, from the surface all the way down to the detailing, it is always a geometric way of thinking about it, visualizing, and this is how we approach everything, like robotics, also from the point of view of geometry, data sciences, also from the point of view of geometry, and so on. And so that makes it somewhat easier for us to manage the physical side of things. It is amenable to intuition in that way, and hopefully when we make these prototypes, it's reflected in the final building as well. So geometry plays a key part, and of course, this phase of research, let's say for the first decade or so, has been cumulative and collaborative, and has been like a kind of scientific endeavor, like all of you, and in that sense, shell structures have formed a large part of that research. And why is it interesting? Because everyone from designers of furniture are like this less popular, less famous chair from Vitra, and they're also this is the office of the designer, and so there's a deep history to shell structures, and especially in the 60s and 70s, and it's been rejuvenated in the 21st century, and there's enough number of people researching the geometry side of it, the structural side of it, the fabrication implications of it, making tons and tons of tools available, and it's a burgeoning field of research and expertise called architectural geometry. In essence, it's geometry that is aware of how it stands up, and it's geometry that is aware of how it will be made. So it's not arbitrary geometry, it's geometry that embeds within it a kind of sense of structure and fabrication. So for us as designers, what we are interested in is this universe of possible shapes, all of them structurally feasible, all of them maybe fabricatable. And so we want to search through this space for specific solutions. And again, in this sense, geometry-based reasoning is very key, and that's why a large part of our work has been in collaboration with Block Research Group, in a sense that some complex structural physics like this could be understood on the basis of two simple geometric entities, the so-called form and force diagrams, and that it also helps correlate and translates well with the kind of physical models that one might make, and therefore you can correlate physical behavior with geometric entities, which is much easier to do than correlate physical behavior with numerical entities. So this is where geometry and pictures are very much part of our ethos in the way we research things. So, and also another key ingredient in this is prototypes and projects. In terms of shell structures, we've been doing this since 2008. This one was in 2011 in Mexico City, working with RX, and then again, exploring topology optimization, again in 2013, and also in 2009, 2010. We tried to do this kind of thing in India, like so here was the first time we used fabric as a guideboard, and it was made by a tailor who had like no idea what he was stitching. It came in a small bag, and they stretched it, and as soon as it was stretched, what became very evident was that the key task of fabricating or making digital geometry is describing it on site. So if you can describe it naturally, it makes ever more sense. And so since then, we've been like trying to look for this kind of natural ways to get complex curvature, like by origami or by stretching fabric and so on. And then it also corresponds well with like the kind of structural physics of these things. And then and it also translates well if you can make prototypes like this building is just a better engineered, more expensive, better quality materials and so on, but the principle is the same. You bend some pipe, stitch some fabric and stretch it, and then you get the building. So and that's the kind of intuition that we want to get from doing prototypes. So it's not like technology development, it's about intuition development for us. And lastly, one of the key ingredients that I tried to highlight in the previous example is this idea of combining the digital with built traditions. Like recently we collaborated last month with a block research group and architecture extrapolated, like in trying to make these kind of complex curvature which are shown to be structurally efficient, obviously, like, in building context and in a real life context, like a very tight spatial constraints and coordinating across several time zones. And also it involves a lot of digital fabrication, obviously, like these technologies developed by Block Research Group of knitting fabrics. But what it also involves is like translating all of that digital information and making it amenable for incorporation of digital, building traditions, especially the laying of concrete that Mexico is particularly good with, or Mexican build traditions are very good in like applying concrete almost against gravity in a way. So in all of these aspects, like really come into to making stuff. Like, so it's not only about like the design of some curved geometry, but it's like a combination of many different expertise that is coming together, and we are quite happy that like we can do this now in a very short time. Whereas like a few years ago, maybe 10 years ago, like just getting this done would have taken a year. In this case, we managed to do it in like 2.5 months, and which I think is a huge case for optimism for our profession and our discipline. And likewise with another topic of sheet metal manufacture and how it corresponds with curved origami. There's a lot of interest on the mathematical side, the geometric side of origami, obviously, but then it also translates well to getting curvature for free almost from sheet metal manufacturing. So you, instead of a straight line curve fold, you just curve the fold, and then you get these shapes rather easily. And that's something that it also makes it easy to describe to someone how to get that curvature. So you give it the 2D plan, and then you say apply force in this way. And so it's such a simple process that like you can even teach a kind of robot to do that. In this case, like all of the intelligence is in the geometric side, and the robot was just folding a piece of metal that like it wasn't even aware that it was folding that. So it's these kind of workflows that like we try to put together per project that really helps. And we try to capture again all the complexities in a geometric way, so that like we can participate with with engineers, other designers, fabricators, and like because we think geometry is a very common language, much more common than like computer programming, let's say, and that many people can contribute to. And other topics, similarly, we are approaching 3D printing with plastics, or 3D printing with like high resolution polymers, and same with like concrete printing. It's not the printing technology, it is like how do you design for it? How do you represent the material computationally such that like designers can actually design for the technology and not necessarily just like design some arbitrary shape and forget about like and leave the making to some engineers later. So in that way you can express some of the inherent processes already in the design, like in concrete printing, the texture is obviously a key part of this, and so that kind of brings us to the full circle that digital design and fabrication is indeed like rapidly evolving, and we are fortunate to be contributing to some of this progress. And year on year, like we see these kind of pavilions get improved in like their scale, size, and complexity. So like, which is like a very positive sign from our point of view, because like what we are interested in is like taking some of that technology and addressing some of the other concerns of architecture. So in this case, like it's a small gallery for mathematics, which since the time it has opened in the first year, already welcomed like 1.2 million visitors. And everything here that you see in this image is like a direct consequence of a cumulative and collaborative endeavor, like so, which means most of the technologies were already given to us, or it has been in development for at least 100 years, and definitely more so in the last 10 years. And so we, like for example, the fabric pod, all the form finding tools that like everyone will know for sure by now, were definitely available, and through our collaboration with Block Research Group, we already knew the insides of it, such a way that we could focus on the minor, like the often forgotten aspects of architecture, like what the people do, what the object should be, where they should be placed, what is the user's experience, how they navigate through space, what is the view depth, and so on. Apart from dealing with like very accurate minor tolerances and so on. So that's one benefit, and it's the same for the concrete benches. For example, we've been collaborating with like this robotic hot wire cutting company, which now after 6 years is like listed on the Nasdaq and they trade publicly. So it was another example of bringing a kind of collaboration that started with like as a friendly discussion over some drinks, and we managed to incorporate that technology and design for that technology. It was embedded in the contract. It was embedded in the way we designed it. There was no other way that you could get the same design, so it could be value engineered, let's say. And also, more importantly, it is embedded in the aesthetic that comes out of it. So the robotic process of just cutting away foam leaves a deep imprint. Like, so it's obvious that like there's no other way to get this. So it's that kind of intention that we want to pursue prototyping and collaboration with existing technologies or emerging technologies over the last decade or so. And what that means is that it allows us enough degrees of freedom to focus on not only getting stuff built and getting stuff built on time and budget, but we can focus on spatial experience, on event spaces, and what the object should be, and so on. So in this case, like we devoted sufficient time to understand what the curator wanted, what are each one of these 200 objects, and some of these are like the difference engine, like which have like history, deep significance, and so on. So every Monday morning we would get a different list of objects, and then we would have to rejig the entire layout, and that was like a very fruitful way to exchange with the client, and because we could focus on this, and like the client is not concerned whether it is made of fabric or not, and so on, and also what they were very much concerned with was like how long and how many things can a person see from most points of the gallery, and which is a completely different way to view the space in many ways. So in that sense, like the fact that like we were spent so much time and project independent research to cumulatively and collaboratively develop the science part of it, that like we could then focus on like the spatial experience and the social side of buildings. And this is a small example which we now want to like formalize or generalize and take it forward. And in that sense, like we've been focusing a lot on like how we can generalize from these unique one-off buildings and address the topic of housing, and not just housing in the sense of the kind of poetic black and white photos of housing, which we are trying to address. Like if you know the structure of the community, how can you develop an architectural language and also spaces in adherence with like the kind of communal structures for long-term communities, let's say, where communities are stable. This is work with our students at the AA DRL, combining digital technologies of printing with like some kind of social use value and positioning of 3D printing in a kind of architectural context that people can at least discuss. By no means is this resolved, but at least we want to bring forward that idea that we can begin to tackle other issues of architecture, not only the structural, not only the physical. And likewise, more commercially, we're interested in more urban densification ideas and new ways of living and co-living and so on, how we can apply data science to lay out, position buildings, position houses in apartment blocks in such a way that it increases the chance of you meeting someone. If you know the daily schedule of people roughly and their preferences, can you arrange the houses in such a way that like you increase the chance of meeting someone that is synergetic with your lifestyle and so on. Yeah, I think I'm done. So, and again, to see within this that housing usually, like there's an idea that like it doesn't need complex geometry, or complex geometry is a bonus or is not integral to housing. Like, so that's the kind of idea that we want to contest. And all the research that we have developed so far to try and position all these languages that we have been rehearsing on the unique buildings, and also historically connecting with like all the knowledge of graphic statics and like the timber framing of previous years, and combining with like new technologies of equilibrium modeling that extend like previous historic knowledge to computational modeling and to full 3 dimensions and so on. So it's a combination for us of like architectural language, these kind of computational research, a lot of prototyping, development of design tools, and also physical making, let's say, like so that we understand the tectonic opportunities of like what we want to highlight, the scale of things, and the proportion of certain things and so on. So when we design these kind of shapes, that we have a reasonable idea of how it behaves structurally and how it could be made. And so these are fat columns, and then you can occupy the full range of fat columns to standard timber framing or and so on. So, and to this, again, you add like the next layer of economics, like that things, you know, architecture has always been concerned with, like economics, because your clients are not willing to pay you any amount of money. Like usually they're squeezing you, and it's true even at Zaha Hadid Architects. So it's something that we are now able to pay attention to, which we weren't able to like a few years ago. That because the physical side has evolved so rapidly, and there's so many tools and so many institutions, like the IAAC and other places, that we can return to our more architectural concerns of user experience and economics and understanding what should be prefabricated and what should be constructed on site, what should be the amenities, what should be the spatial experience that you can sell, and also how best to communicate all of this. Like, because it's not easy to communicate the value of something to the wider audience. So we are also now have a small team within our team dedicated to trying to explore visual language and how like things like rendering and visualization usually is like cast aside as like some fake thing to do, but like we see deep value in visualizing things as realistically as possible, because it's indeed these things that the general public is consuming. So, so we are very much interested in developing research and marrying the visual images that are being produced with like the research that goes into them. And so like so this is a brief glimpse of like things coming out of the studio right now. And so the various things, ultimately we want to move to a place where the physical and the social and the commercial are all integrated, and somehow like we can revisit the work of Eames and others and the manifesto of Eames in the 21st century, where we think right now we have the technology, we have the physical technology, we have the data technologies, and we have the need for to implementing such a manifesto, particularly in the housing realm. So that's like our. So I'll leave you with like a video, which is where we hope to go, a kind of Tinder for housing, where you can choose not only your house but also your neighbors, which currently you can't. Again, this is work coming from our studio at the AA DRL. And so the idea is that like somehow to make and frame a context for digital fabrication in the sense of community building, in the sense of urban densification, and so on, which we think would be a very ripe and fruitful platform for digital fabrication in an architectural sense. So I'll leave you with this video, and thank you very much for your attention.
Thank you very much for the impressive lecture, Shajay, and very nice to see some glimpse of what you're working on these days. I'm sure that there is a lot of questions in the audience, so I hope so. So I'll let you 1 minute to digest a bit all of this. We had the chance to just spend an hour and a half of interview with a student of Master in Robotics, so I have plenty of questions that we already answered and looked into it. But effectively, there's a huge challenge to understand where digital technology will go and how we can extract the most out of it. No? For what is the question that we try to solve? And I really appreciate that a big company like Zaha Hadid is trying to make this turn. As you said, it's quite recent. It's like 2 years, 3 years that you clearly have fish. You display this turn around trying to add a social value. No? I've seen also some glimpse where you start to speak about environment and economics immediately, but and it's something that I'm sure your client as well, the richest one, are interested. And I'm wondering if you also speak about the performance of your building, in the sense that not only in terms of wow effects that we can agree on, but I believe you also have to speak about structures, how much you might save materials, how much you might be performing better in terms of the efficiency of the building, maybe sometimes the engineering aspect of the building. And I'm wondering how you combine this with the wow effect and this other social aspect that you were looking for.
Yeah, I mean, thanks for the question. I think that's somewhat central to our domain, in a way that, like, whilst we are researching, I mean, of course, if you're researching robotic construction, or if you're researching structures, or computer programming, or whatever, like, it's difficult, or it's almost next to impossible to address like all the wider concerns. You can only address very specific things. But the benefit of like having the discipline and the profession having invested, like, let's say 20 years in this recent 20 years, and also previously in the 60s, and like maybe also in the 20s and 30s in sporadic spurts, is that like we now have architects, not as researchers, like as companies, to make use of all of this research, and then focus on the social side, or I mean, many engineering companies are now also focusing on the environmental side, which is also equally important, like environmental sustainability, and we think like the social sustainability is equally important to be addressed now, not after environmental sustainability is addressed, which is usually what if you speak to an engineer, they think like there's a pyramid of needs, and like environment comes first, and then the social stuff comes later. But then, who are you saving the environment for? Like, we think like it needs to be addressed with equal amount of care and rigor and vigor. And that is only possible now because of the work of people in this room and similar rooms elsewhere. That there is lots and lots of tools and knowledge available, and we are beginning to see small spurts of that, or glimpses of like how that knowledge is getting applied. Yeah, maybe it needs to start with like companies like ours, like, but by no means will it be restricted to that. Because like, for example, in China or like these younger companies like Penta Architects, I mean, we follow them just with as much interest as we might follow Norman Foster's Instagram, for example. And so, yeah, so there is, you can focus on things because all of this technology is maturing rapidly. And I think, so you can choose whether to focus on the environment or the economics or the social side or community building and so on.
Thank you very much for the answer, and also challenging a bit more where we're going. Does someone have a question that you want to dive in? Oh. Is there some people moving there? Really? I'm surprised.
Thank you, Shajay, for the presentation. It's great actually to see from coming from a very field that has been pioneering the digital computation, but also digital fabrication into very complex forms, to now give a shift towards issues that they are more related to social environmental aspects. Now, to me, that is the topic that I want to talk about. That's also the title that you gave to your lecture, and I think that is important that we start discussing it, although sometimes it feels that we're a bit far away, because computation is actually bringing, apart from optimization, apart from structural performance, is design and aesthetics. And when we're talking about mass production, which is what you were a bit showing in the beginning with the mass-produced car and the industrial revolution, what we saw there is the standardized, like the typical standard repetitive form. Now today, there are certain companies, researchers, or even startups, they are working on the topic of prefabricated housing, accessible housing for the community, customized housing for the community, but with almost minimal design, right? So it rather feels that design, it keeps on being the kind of luxury that not everybody can have access to. And my question would be, whereas computation and algorithms can help us to actually not have to repeat designs and designs that cost a lot, but rather than how can we learn from the process of design in order to be able to offer that into kind of a more accessible way?
Yeah, this idea of, I mean, like, came up with the conversation with the students last an hour ago, and I think like one of the key benefits of parametric or computational or algorithmic design or so is that it can occupy a wider spectrum. Like, it's no longer necessary that like you build an empire on Chanel, like they only do like a certain boutique bags and like nothing else and so on, or like even architects, like we can occupy a wider spectrum because things are understood parametrically and like cost becomes a parameter, as long as you can parametricize whatever it is you're intending to explore or address, in other words, if you can like kind of communicate the problem or describe the problem or formalize the problem in a way that the computer can participate in finding the solution, like I think there's every chance that you will actually find the solution, because and that's one of the advantages of like computational design, is that you can occupy the full spectrum. Like you can have where cost is not a problem for some people cost is a problem, and also cost itself can be very differently understood. What is the social cost, what's the economic cost, what's the cultural cost, and so on. And so it's in this diversity of a universe of possible solutions. So it's basically opening up a wider landscape, a wider solution space. So if nothing else, it improves the probability that you will find the answers there, as opposed to something that has a solution space of 3 objects, right? 3 solutions. So which is what I think design without computers is. Like you have naturally evolved to produce certain things, and you will produce those very, very well. But like you won't explore much else.
But can you use, let's say, machine learning or AI or advanced algorithms in order to create certain learning into the design process? I mean, a couple of days ago, I was reading about this startup that they are actually offering design services for $20 to $50, right? So anybody could actually have a more sophisticated design of their house just because they are actually building upon data of previous designs in order to optimize certain parameters, and they offer them in a kind of a very low price. Because the time that you invest in the next design is much less than you've been doing before.
Sure. Well, yeah, I mean, we welcome like these kind of ideas that like you bring competition to our jobs, which I think is very good, because I think that's going to instantly negate a lot of the retro arguments like currently that we see in certain academic circles, like somehow return back to modernism and return back to drawing by hand and so on, like as though we're losing something. Because like as soon as our jobs are challenged, the way we will deal with it is like not going back to the watercolors, but by leveraging technology, and that's I think is a good sign that like there are other companies like Google and others interested in the built environment, which means that like there is real value in these technologies and the research that like people in this room and elsewhere have been doing, that it's reaching a threshold where it will become disruptive. Like, and most other fields are not so ripe for disruption, because for the last 3 decades or so, productivity in the construction industry is like this, every other industry is like that. So it's obvious that like other companies like AI researchers are beginning to look at like the built environment, and it's for us to now position design as integral to delivering the solution, right? And like so, at no means are we saying that like computers is the only way to get there, like, but we need human skills, and it's like augmenting our intelligence with computers and with machines. I think there's no shame in that, and it's only going to make us better, and we can take that opportunity to make design more accessible. Like, because if you think of making design more accessible, you will think of more different parameters. Let's say you will think of design differently. You will leverage computation. You will leverage digital fabrication. And so I think democratization and computation are very much deeply linked. Like, you can't get one without the other anymore. I don't think. Like, it's the kind of big point I think.
I think now, if you ask the majority of public, when they see something produced with the digital fabrication method you have presented now, they would probably have this impression that this object or structure comes with this tag of exclusivity, expensive, impressive, and very cool. And what my question is, do you think this kind of impression itself that it limits the pursuit of accessibility of digital fabrication? And I'm not sure if that makes sense to you. So.
Yeah, no, I mean, there is definitely the idea that it's going to cost more, which is 100% true. Like, it has to cost more when you're making the first few things. But now already we're beginning to see not only our practice, but like even younger practices be cost competitive, which means that like the industry is maturing enough. There's enough wide availability of things. And if you think about like concrete, like in 1915, like when Corbusier made that diagram, like, and the first buildings were obviously not cheap. And it was Villa Savoy, and like it was made for like the mavericks of that time. But over time, like cost of things go down, because the only way things become affordable is if you increase supply. And how do you increase that, like through education, through a widely available, I mean, it's clearly better to pursue digital design and digital fabrication. So it is a certain, I mean, there's some amount of lobbying involved in all of this. Like there's wise beam suddenly everywhere. It's because it's not only because technology is everywhere, it's also like, you know, there's government policies that are helping and so on. And so, yeah, digital design, I think, like in the next decade will be very different, perceived very differently than in the previous decades, because no one has similar ideas that AI stuff costs more. You know, like almost every other day you will see AI is disrupting the industry, and what used to cost thousands of dollars is now costing you $5. And no one talks about AI costing so much more. Like, and I think digital design is going to come to a similar state when the knowledge is more widely available and the machinery, the price keeps dropping, and obviously if you consume less material, the production processes will shift over to a different paradigm. Because right now there's a latency, a reluctance to change the existing paradigm of construction, even though clearly you will use less material, because the other legal procedures and procurement procedures and construction labor is somewhat like stuck in a different paradigm. So I think if we reach a critical mass of like maybe 20% of buildings being digitally fabricated, it's gonna flip, and then it's gonna become mainstream. Like until we reach that critical mass, yeah, we have to deal with this kind of image that it is exclusive and expensive. Yeah, but there's nothing inherent, I think, about digital design that makes it exclusive.
Yeah. And do you see this change happening anytime soon?
Yeah, I think so. It's up to people like us to make it happen. And also, I mean, countries like China and India, like and growing economies is where this, I think, like the leapfrogging will happen in growing economies. I don't see Europe taking the lead in this because, or even the US, because you know, it's growing by like 2% a year. Like that's so if like there's no real economic fabrication yet, unless whereas in India and China and other places, like they can leapfrog an entire phase and directly benefit from the changing the paradigm.
Interesting. I hope that we have a bit more Europe. And it was a really interesting discussion. I really invite you to take questions around the beer that we offer after. And thank you very much for your intervention.
Thank you.